Hi, welcome back. Last episode we learned how to pass data from BASIC to assembly. So today we expand on that topic, also learning how to do the other way around, how we get data from assembly into BASIC. And also we're gonna understand a bit more about the different variable types that we have in Applesoft and how they are internally represented and how that affects how we pass data between BASIC and assembly. So here you see a page from the assembly lines book that shows you the entries in the variable table. So in memory, we have a table with all variables in our program. And the three variable types that we have in Applesoft BASIC are string, integer, and real numbers. Real numbers are basically floating point numbers. So starting from bottom to top, we have the entry string, the string entry. So each entry is 7 bytes long. In the case of string, you have 2 bytes for the name because variable names can have up to 2 characters in Applesoft BASIC. And then you have the length of the string, and then you have a low-high pair of bytes that points to the address where you can find the actual string. So remember, this is not the string itself, this is an entry in the variable table. And then the next 2 bytes are just zeros because we have this fixed structure with 7 bytes. So it's always 7 bytes long no matter whether you use it or not. So there's no point in choosing one variable type against the other for saving memory space because they all use, like the variable pointers in a sense, they all use the same space. So for an integer, we also have the first 2 characters being the name of the variable. And then we have the high and low pair that represents the actual value. So this is not a pointer to an address. This is the actual integer value. So we use 2 bytes to specify the integer value. And you see that this is a bit different than the usual high and low order that we have in the 6502 processor. This is flipped, so you have first the high value byte and then the low value byte, and then we have the padding of 3 zeros. And finally we get the real or floating point number, where we have 2 characters for the name, and then we have, this is for floating point logarithmic representation. We have an exponent and 4 mantises. And this is how we represent in memory. So let's take a look on how we can use that to get our variables from BASIC to assembly and from assembly to BASIC. The first example shows us how to read an integer variable that is set from BASIC, and then we read it in the assembly program. Before we check the assembly code, let me show you the companion BASIC code. So what we're doing here is we are setting a variable called a% to have the value 258. And then we are calling an assembly routine that's on memory address hexadecimal 300. Passing this a% integer variable. And then this routine is going to do something, and we're gonna print the contents of 2 memory addresses, decimal 896 and 897, which are the equivalent of hex 380 and 381. Because on this value, on these memory addresses, we're gonna find the value 258. So we're gonna get this a% variable from BASIC, and then we're gonna store this in another memory address, and then we're gonna check whether this has been correctly stored by printing these 2 memory addresses. And what we expected is to have a decimal number 2 on the high byte and decimal 1 on the low byte, because those are the decimal equivalents to the high byte and low byte values. And remember that the order in an integer is high and low in this order. So the assembly program here first is checking for the comma, right? This comma here, we discussed this last episode. And then we get a pointer to variable a%. So the registers Y and A are going to point to the address where that variable is stored. And then here we are checking the type of the variable to see whether this is really a number or it's not a string. And the way we do that is we call this instruction that moves the current value pointed by the Y and A registers to a floating point accumulator memory address. And this routine that is provided by the Apple monitor does exactly that. And once we have this floating point accumulator loaded, we can call another routine called checkNum, which will basically check if the value pointed to by this accumulator is a number. And if something goes wrong, then we're going to have a failure at this point. Otherwise, what we do is we clear out the Y accumulator, because this is kind of masked by these two routines here. Then we load our variable pointer. We do a loop here where we're basically loading our variable pointer. And then we are storing this in the data +1 and data addresses, right? That we are storing the high byte on, the low byte in data +1 and the high byte in data. And you see that the order is kind of flipped because that high byte first, that inversion that we mentioned before. And when we end this, basically we have taken the value of A% and we have put this in locations 380, 381 hex, which are equivalent to A96, A97 decimal. So let's see whether this works. And if it works, again, we should see two numbers, the number 2 and the number 1. And you can see that that works. Here we have the next exercise doing the same for a real number. And the basic code is pretty much the same, but now instead of A%, and the percent indicates that's an integer, we just call variable A, which means it's a real or floating point number. And we change also line 20 to reflect the same thing. And here we are using slightly different routines. So we're checking the comma, we are calling the evaluate number, which will populate the floating point accumulator, and then this get address will check whether this is a number. And then we put the value that we got from BASIC into data and data +1. So these routines are slightly different. This is able to deal with both integer numbers and floating numbers. So this is just a cleaner code, less work to get the same result. And we can see that we get the same result by running the program. And you can see that now we are using, instead of an integer, a real variable, but we are still getting our 2 and our 1. So because this is basically putting the integer value of what we have read into the floating point accumulator. And now we go to the string example. And here's the string exercise. And the basic code here looks a bit different because we're just passing the string, but we are not printing the output. We're gonna check directly memory using the monitor. So we call our routine passing $1. And what we do here is we check for the comma, and then we call this routine that will take the string and put the pointer to the string to the FAC, to the floating point accumulator. We're gonna check whether this is really a string. And then using pointers to the high and low of the FAC, we get the length of the string and also the address of the string, right? So the address of the string is in var pnt, var pointer, and the x, we have in the A register, we have the length. So we start a loop that goes for each one of the characters, so the size of length, or the length of length, and we populate data plus 1, data plus 2, data plus 3 with the characters that we received. So we're gonna have in location data, which is hexadecimal 380. We're gonna have a copy of the string if everything goes well. So let's assemble and run the program. Okay, so now we have to get into the monitor. We call -151, and now to see the contents of memory positions 380 through 383, we do it like this. So we have values 54, which is the T character, and you can see that the word test starts and ends with a T, so we start with the 54 and end with the 54. So this is the T, this is the E, this is the S, and this is the T. So we succeeded in receiving this string from BASIC and copying it to a memory location where we could do whatever we want with that. So that is how you receive a string set from BASIC and you get it on the assembly side. So now we have to do the opposite directions, right? We have to get variables that we set in assembly readable on our BASIC programs. So let's start with the integer variables. And here's the BASIC program. In BASIC, we are doing the opposite here. So we start by poking or setting the memory address A96, which is hexa 380, with the decimal value 2, and then the next byte with the decimal value 1. And we know that these high and low bytes, they make the decimal number 258. So we put this in this memory address, and then we call the routine. And what happens here in the routine is the opposite of what we have seen before. So before we were taking what was in the var pointer, right, the value that we got from BASIC, and we were storing it in data. So here we do the opposite. We load what's in data and we store it in var pointer. So we end up with variable a% containing the value that was in the data position, and the data position is the one that we just poked here. So when we print the integer here, we expect to print 258. So let's see if it works. Yes, it does. So let's do the same with a real number now. The basic code for doing the same with a real variable, it's exactly the same with the difference that now the variable is not a%, the integer one, but only a, like a real number value. And the assembly program is also the same we had for setting the variable from BASIC to assembly, but now we do it the other way around, and we start with the value that's in data, and then we put this in the pointer that, the pointer we start with here, and then we put in the pointer of the variable that we receive from BASIC. Let's see this in action. And we still have the same 258 result as expected. And that takes us, of course, to the last example, which is dealing with a string. So the basic program here is slightly different because now we have to poke sorry. So we have to poke the 4 characters for the string test. So in starting on memory position A96, we put the values 84, 69, 83, and 84. And you notice these are decimal values differently than the hexadecimal values that we have seen in the monitor. So that's why the numbers are different. But these are the decimal values for the characters T, E, S, T. And then in the final position, we put a 0, which is the end string delimiter. And then we call the subroutine passing the variable $, and we expect that the variable $, at the end will contain the value test. And then we print, we should see test. And here the program is, again, the opposite of the prior one, where we load the contents of data into that memory address. So without further ado, let's run this program and notice that we get the expected result. So in this episode, we have learned how to read from basic to assembly and set from assembly back to basic values of the three possible variable types we have in 6502 assembly and Applesoft BASIC, which are strings, integer numbers, and floating point numbers, also known as real numbers. That's it for today's episode, and next time we start checking in graphics. So see you soon.